So tonight's speaker is Paul Burt. He's the product marketing manager at CoreOS, and he's also one of the moderators of the Kubernetes subreddit on Reddit. And here we go, Paul.
Sweet. Thank you, Tom. Round of applause. And I like the quip about rectangular if you're pedantic. Like we're all engineers here, so I get the feeling I know the answer to that question. Anyways, tonight we're going to be talking about what the heck Kubernetes is. Jim Zemlin of the Linux Foundation called it the Linux of the cloud. So everybody gets it, right? We're good. No, yeah, it's confusing. It's a lot of things to a lot of people. So my goal today is to try and break it down to the core concepts, the essentials that you need, and then to give you tools and resources that you can go and dive into to get sort of a deep dive into it. And I have to apologize before I get started here. I'm getting over a cold, so I'm going to cough a little bit. We'll just work through it. So let's see if I can get my slides to actually work with me. There we go. All right, so this is me. As noted, I work at CoreOS, where we do a lot of work on Kubernetes. Our CTO was the first product manager of Kubernetes, and we are one of the top 3 contributors to the Kubernetes code base. We've been contributing since the first version, so company CoreOS is deeply involved in the project and the space. And in order to talk about this, we need to talk about what containers are first. So if you're rolling your eyes right now, I apologize. I'll try and make it entertaining. There's a lot that's been going on in the container space anyways, so can't hurt to make sure expectations are all in the right place. Like you may remember earlier in the year, Docker rebranded to Moby, and that was a big mess. You know, everybody in CoreOS that day was kind of running around saying like, so I think this is what it is, but I'm not sure. I think it's, and I think a lot of people are still figuring it out. So containers in general, that's a bigger question. What's a container? Well, it's a tar file. So it's basically a zip file for you folks who are on Windows or a non-Nix type system. And that's just an archive. It's a bundle of files. More specifically, containers are tar files, this bundle of files, plus a couple system calls to Linux. So cgroup, chroot, unshare, nsenter, bind mounts. These are things like namespaces. It's limiting the scope of a program to be able to only see specific files and directories. All of this adds up to a lot of isolation and a lot of good things that you want generally when you're running a program. And the real answer is containers are Linux magic in my boat. The modern era of containers really came about in around 2008 when IBM started working on LXC and released that publicly. Docker really catapulted that into the mainstream. It's sort of, you can think of LXC sort of like Friendster and Docker as Facebook. The idea originated somewhere else, but Docker really made it sleek, easy to use, and that is the flavor of containers that most of us are using today. If you are curious more about those system calls, those sorts of things, what nsenter is, what a bind mount is, these are 2 excellent talks from coworkers of mine. The first is Containers from Scratch by Eric Chang. The link here is a link to his blog, where he goes in deep on exactly what that is. Liz Rice also has an excellent talk she did at a DockerCon about this. And Brian Redbeard also has a great talk he did for Sysdig, where he talks about building your own container from scratch. So if you ever wanted to do that, that sounds exciting to you, you like DIY projects like building birdhouses, that's a great talk to check out. Cool. So that's what containers are, but why use containers? Why jump on the bandwagon? Why cargo cult a new piece of technology, revamp all of your infrastructure? Why do you want to use them? I think that's the more interesting question, and I think the simplest answer is hell is other people's development environment. It's not hell is other people, it's hell is other people's development environment. And I think there's a lot of like shirts and memes going around about, well, it worked on my local. I think everybody's had that conversation. It's a common experience all of us share if we've been doing operations or we've been building apps for any amount of time. And containers prevent that. It means if someone's using Node.js version 4, some ancient version, and I need an up-to-date version of Node, I don't have to worry about their Node.js version being on the machine and conflicting with my version of Node.js. Same deal with library versions. This comes up a lot with Ruby. Nokogiri in particular is an amazingly annoying gem to have bundled into your application because everything seems to use a different version of it. And dealing with those version conflicts is a headache. Containers prevent that. Containers let you run whatever version you want, and then you just connect your containers together, kind of like little Lego bricks, and everything supposedly is going to work, or at least that's the dream they try and sell you. So, how do containers work? Well, when we talk about a container, usually we're talking about both a runtime and an image. So here you can think of the runtime personified as an active agent, something like this monkey here, doing something to the container. It's starting processes, it's running plugins like CNI, your networking plugins, your storage plugins. It's managing the whole life cycle of that container. It usually also downloads containers, deals with fetching the image, that sort of thing. The image is actually just a very thin file, very lightweight, that basically says, if you don't have this layer of the container, go download it, and then we're good to go. You can run it. This is something similar to Containerd or runc, if you've heard those terms floating around. Those are all components of the runtime. Specifically, the container image is kind of the manifest file that actually tells the container how it's supposed to be built. So this is what you're used to working with if you've built your own Docker file or looked into things like that. And that is subject to the OCI image specification, which just hit 1.0 this year. So you may think of Docker as this giant collection of everything. This is something that CoreOS actually famously fought with Docker over for a while, and now we're all best buds now that OCI is out. And what OCI does is it separates the world of containers into two distinct fields, this image spec and how to run it. And essentially what the OCI spec gives you is an image manifest, an index of everything that's in it, file system layers, configuration. If you're curious about the details of this, there's an excellent talk by Jonathan Bull, 10 minutes of your night. I highly recommend checking it out. He walks you through using a tool called Scopio to actually just walk through a standard BusyBox container. Will change how you look at containers and what's packaged inside of them. You'll get a lot of understanding out of something like this. So that's it, right? That's containers. Well, we still have to think about how to run them is the reality. We've talked about why they're cool. Maybe we're on board with the philosophy, the ethos, but how do we actually get them going? And you might be thinking, well, hey, this is a talk about Kubernetes. This is where we do Kubernetes, right? And the answer is no. So actually, if you're just running containers, systemd is sufficient for management on a single host. If you're plugging in a unit file, something like this is taken from the CoreOS documentation. This is really all you need to run a container. So you can see it's starting with some Docker commands for various hooks in the lifecycle of the container. It's telling it how to restart, what needs to be installed, what to do after the app crashes, that sort of thing. So unit files and systemd take care of a lot of what we care about. And this is actually really nice for a single server if you're just running your own website, if you're running your blog on Kubernetes, which is crazy overkill, but a wonderful education experience. This is probably what you would do without Kubernetes first. You would run it using systemd. Systemd gives you the lifecycle checks. If it crashes, it'll restart it. And it gives you some sort of tally of what is expected to run on the computer. And most notably, everything is sort of immutable, declarative, all those nice buzzwords we like throwing around. So why care about Kubernetes if systemd solves a lot of these problems? And the answer is distributed systems. They're awful. They're a really hard problem to solve. So there's a lot of philosophy that floats around distributed systems, CAP theorem, pets versus cattle, mutable infrastructure. You're probably all aware of these trends, being that you're at a DevOps meetup right now. So I probably don't have to explain this too much, but it really boils down to you want things to be able to be checked into Git, and if something goes wrong, you just kill the server, boot a new one, and you're good to go. So Kubernetes relies on a lot of that. But when you think about building a distributed system, a lot of people are like, oh, that's not too hard. I can do that myself. And this is like famous last words of every engineer. Facebook? Oh yeah, I could build a Facebook clone in a weekend. That's fine. And you probably could. You can get 80% of the way there, and then that last 20% just gnaws at you. You can't make any progress on it, forward progress, because it's the edge cases. It's the little things that go wrong. And when you're running a distributed system where you're running hundreds or maybe thousands of containers, things going wrong goes from an odd scenario that you run into once every couple years to a guarantee. It's a statistical eventuality. It's not if, it's when. You're serving billions or trillions of requests a day. Weird stuff is going to happen for sure. So these are the famous fallacies of distributed computing, and this is really what Kubernetes is solving in some ways. This is from an engineer, I think Peter Deutsch, who worked at Sun way back in the day. And the lesson I pull from this is just distributed systems are hard. And Kubernetes comes from Google, comes from decades of experience where they've been using containers for a really long time before Docker was even a thing. They have systems called Omega and Borg, which are the predecessors of Kubernetes. And Kubernetes was born out of the lessons they learned from both of those. So there's some great white papers online you can check out about Omega and Borg that can kind of teach you about that philosophy if that interests you. Cool. So distributed systems are hard. With that out of the way, let's talk about what Kubernetes is, and then we can talk about a little more about why and how it works. And hopefully, if the demo gods smile upon us, we'll have a working tour here. So for a really detailed nuts and bolts look at Kubernetes, thankfully there's a certified Kubernetes exam you can take right now, and actually just studying for that exam will give you a wonderful understanding of how the system works. So Heptio has a great guide for acing the exam itself. And then there's also a wonderful GitHub repo that has a lot of links to important articles for each chunk of the system that you might run into on the exam. For our use cases, I'm going to simplify things dramatically and just say that for Kubernetes, there's a control plane. It's a master node that it's the brain of the system, keeps track of what's supposed to go where, it does scheduling, it controls and sends signals out. And there's a small application called a kubelet that rests on every worker node that receives those signals and then takes actions based on those messages that it's getting from the central server. But we should be aware, that driving a car is different than building a car. So I am not going to dive too deep into building the car with you tonight. There are much better people to do that talk for you. And I probably don't have the time to go through all the nuts and bolts here tonight. So I'll say definitely check out those guides for the certified Kubernetes exam. Those will give you a real feel for the individual components. But for driving, if we are talking about a gas pedal and a steering wheel, the bare basics, we can just talk about pods and services. So these are primitives that Kubernetes has. These are somewhat unique. There's a little confusion. I think Docker Swarm uses similar terms for services that don't quite match up. But I'll just do the Kubernetes version for you all tonight. So a pod is basically the idea that a container is going to have one application in it, or really one process in it that's running at any given point in time. That's the ideal world, but a lot of applications that are actually like a usable thing probably consist of multiple processes. You might have a sidecar process that's doing logging, for instance. So if you want to group those things together, pods are the way you do that in Kubernetes, and pods are guaranteed to share the same network namespace. They'll communicate with each other over localhost. They will all be bound to the same IP address, and they also will share resources like disk. They'll be scheduled on the same system or VM. They're guaranteed to be clumped together, which is a really nice feature. So this is the basic unit that Kubernetes works in. It's not the container itself. It is the group of containers that comprise your application. And indeed, if you choose to use frameworks like Helm, which make it easy to install applications onto Kubernetes, most Helm charts work in this sort of terminology as well. There's multiple pods clustered together, and Helm helps you install that onto your Kubernetes cluster. So given that we have pods, it probably sucks to reference them by IP address if we're going to have hundreds or thousands of them, because this comes from Google after all. That's the scale that they're working at. So we probably want something a little more robust than referring to things by IP address. So services give us that option. They let us apply labels, give things names, and apply rules to how we want those underlying pods to be accessed. So that's what the service does. And with those two tools, we should have enough to give this a whirl to see how Kubernetes works. Now, I work at CoreOS. We make a distribution of Kubernetes called Tectonic Sandbox. It's container Linux, the Linux operating system we make that auto updates, combined with kind of the best of breed open source tech for Kubernetes. There are a lot of other distributions. Basically, any serious distribution that's out there right now should have an equivalent to what I'm going to demo for you today, which is a way to try Kubernetes on your local machine. And on top of that, they should also have tutorials for you to try. So if you just want to deploy a simple toy application, this should give you a feel for how it works. Cool. Let's see if my cluster's still up. There we go. So I have my Tectonic cluster here. There's nothing running on it at the moment. As you can see, everything's looking good. And then if I just go to CoreOS.com and go to the Kubernetes or Tectonic section, there's a tutorials link, and it leads me to the link for this sandbox app. So what I have already done is sort of followed these instructions to install the Vagrant app. So the first step for this, let me increase my font size, do this one-handed, would be to type Vagrant up. Should already be running in my case, so we shouldn't have any issue here, hopefully. Yep, there we go. All right, so we're good on that front. And another part of this process is to just connect this application called kubectl to my Kubernetes cluster. So this is how I'm going to control Kubernetes. I can do it from my fancy web interface as well, if I really want to. So, you know, I have the option to deploy things from this screen, but this is probably where most of us work day to day. And if you want to get familiar with Kubernetes, this is the best way to do it, is from the command line. So I'll try and do this from there. Oh. No resources. All right, let me see. Okay, there we go. All right, so I have no pods running at the moment, so that's okay. So what I have is a set of simple files that will make up my application for us tonight. So let's take a look at what those look like. Increase the font size here. Cool. So this is the first other primitive we'll bump into in addition to pods and services. This is a deployment. Deployments basically just give you a strategy for how you want to deploy your pods. So in addition to just installing the thing on your cluster, there's a lot to think about when it comes to a distributed system. There's all the CRUD operations. It's reading how many are actively running right now. It's updating them. How are we going to do that update strategy? And the deployment defines that update strategy for us. So it tells us how much we want to hold on to. We can see the strategy is named as a rolling update. There's some knobs to tweak here and there. And most importantly, we're defining the app that we're deploying. We're telling it which containers are important, and then defining probes to tell us whether our thing is healthy or not. Was there a question? No? Okay. Similarly, service is very simple. Basically, the only important thing to note here is that this selector is the same as the selector that we had on our deployment. And we're just telling it to expose port 80, so standard web port. And finally, since we're not hosting this on the cloud, since we don't have a nice AWS load balancer or something like that, we need to put our own reverse proxy in there. to route traffic for us. It might be nightmarish to just plug things directly into the pods. So we've got that defined as the ingress object, is what Kubernetes calls it. This is very similar to the service, basically just defines a different object type and the URL that we want to route it to specifically. Cool. So let's try installing these. Alrighty, so kubectl create is just going to create the object type defined in those YAML files we were just looking at. So we've got one for simple deployment. And no, it's not. So I'm installing those right now by running these commands. So at the moment, we have all three of our pods have actually already started. I entered this with the watch command. And if I exit that and I just run get all, you can actually see what's running and what's not. So I have a service for Kubernetes, which is hosting my web interface. And I have a simple deployment running right now. The simple deployment creates something called a replica set, which is that bottom element. That's just sort of a weird legacy shim that's put in place to help manage the pods, but you can sort of forget about that at the moment. Yes, so there are three deployments. If we go back to our file here, we specified that we wanted 3 replicas to be deployed here. And now Kubernetes has deployed those 3 containers. They're running. It's running probes against those containers every 30 seconds. I need to actually expose the service and then set up the routing so that it knows to route me into the Kubernetes cluster from the outside if I'm accessing it from a web browser, which I am. So I will also install my my service next. Sorry, say again? The question was on AWS, we have an Elastic service that's always running. There's something running on AWS's servers. We don't have to worry about it, but since I'm running on my machine, I have to set it up. So what is running was the question. So the answer is we have the pods running. The deployment is taking care of that for us. We've specified that we want 3 of them, and we can see here that we do have 3. Now we're setting up the service and the ingress to actually appropriately route that to the web browser when we try and access this from the web browser. And when we view it in the web browser, it will show us exactly what we're running here. So my service has been created. Wonderful. Oh no, is this not called simple ingress? Okay, it is. Whew. That one fell off the list, I guess. So if I run get all here, I should see some new items here. Yep, so I can see simple service is a new item in this row. That's good. That's looking good. And sort of strange, ingress is a somewhat new resource. So it doesn't appear in the all. When I say get all, I have to actually specify specifically I want the ingress. So now it's telling me what to visit to get to this ingress. So I'm visiting console.tectonicsandbox.com. And then going to the route that's specified in that ingress file. So in my case, that route is simple deployment. And I'm doing this one-handed, so I'm going to cheat and click the link in the documentation here. Let's see. There we go. So as you can see, we have our cookie shop application. It's basically just an Nginx image running in a container. We've got 3 of them. And if we were to watch our logs as we were hitting and sending traffic to this, Kubernetes would be round-robining requests for us automatically to each of the 3 containers. So it's doing the load balancing for us. Cool. So this is good. Now onto the hard stuff. Installation's easy. Takes some time, but it's not too difficult. Cool. So installation is the easy part, as I said. Difficult part is updating things and having our service not be interrupted while it's updating. So as we remember, we specified a rolling update strategy in our deployment. So I can roll over to my deployment, see that looks good. So say I want 5 of these to be running instead of just 3. I've got more load I need to deal with. And I want to update the version of my application. Can do that, hit save. And all I'm going to do now is that same command, but with apply. So I'm just saying this thing may already be created. I want to apply this new YAML file on top of that other YAML file. If you have something that is the same selector and label here, update that for me. Cool, so let's hit enter. So I set this up this morning and just let it run because sometimes I've actually tried to do demos with this places and Vagrant just starts going like, oh my God, I have to download 5 gigabytes. Hold on a second, which doesn't go well for demos. Cool, so let's see if everything's updated. That looks good. We've got 5 versions of our service running. Looks like there's a mysterious 6th version. It may be one that is the old version that hasn't been brought down yet. But this is promising. So if we were to refresh our cookie store app, we will hopefully see an update, which we do. So we have seamlessly updated our web application. Kubernetes did the rolling update strategy for us. It drained traffic from the nodes that were getting it. It then took it down, put the new container in, and did it methodically for every container on the system. And you all are probably very familiar with the Knight Capital story that came out a couple years back. They were a high-frequency trading firm. This is very important stuff. They had 10 servers they were managing, a small number compared to how many you manage with Kubernetes. And because they failed to update one of their boxes and they were reusing a flag from a previous version of their software to do something different, that one box that didn't get updated for them on their high-frequency trading platform ended up losing $480 million in 45 minutes. So having things up to date and having assurances that they're on the right version, they're doing the right thing, is very tricky, and it can be very costly if you do it incorrectly. And as you're probably familiar, these things get far more complicated the more machines you're managing, and that is the beauty of Kubernetes. Whether I'm running 1 machine on my local or I'm running 100 in the cloud, these commands are the exact same. I'm not doing anything different. I'm just saying I want 200 instead of I want 2. That's really the big change that happens, and then Kubernetes sort of manages the rest for me. So that's the beauty of the system. Cool. Yeah, let me toss the cube here.
Hello, can you hear me? Oh,
yeah.
Good. So I understand that it's doing round robin within a pod. But let's say you have a cluster, which is a group of pods. Would it do round robin, let's say onto a different pod if those first 3 those first 3 instances are used? I guess that's part 1. And part 2, I think you just mentioned, Jesus, I should have written. Yeah, let's just leave it at that.
Yeah.
Yeah.
So there are horizontal auto-scaling features in Kubernetes, so you can basically set it up so that it can provision new instances of itself if additional traffic comes in. It's not actually doing round-robin routing within the pod. Each of these pods that are here right now, let me see if I can get an updated list. That's just the 5, yeah. Each of these is a unique pod group. So if I had the logger defined for each of these and say each of them had their own key value store associated with them as well, we would have 5 of each of those in groups together, and it would round robin route to the pod itself. It doesn't distinguish between the pod and the underlying containers at that point. The service basically just says, this is the container that's going to accept the traffic, and then let it do whatever it wants to do beyond that point. Yes, so the question was, I mentioned that it's as easy to manage 3 instances of something as it is 200. That's the beauty of Kubernetes. So say that one machine is overloaded. Is it smart enough to schedule future work on other machines? The answer to that is yes. Right now, the default bin packing algorithm for Kubernetes is efficient. It will try and pack everything into the smallest amount of servers that you need. And then you are able to specify taints and tolerations and a couple other sort of fuzzy definitions for how much capacity you want your servers to have in excess to prevent them from crashing or doing weird stuff when you run low on memory, that sort of thing. So you basically set that all up when you set up Kubernetes.
Hi. So my question is regarding a sentence you started. You were saying something like where Kubernetes really shines is, and then some battery for the mic ended or stopped.
Yeah.
So I'm not really sure. I didn't get the end of that sentence.
Yeah, so the question was where does Kubernetes really shine? The mic cut out. So in my opinion, Kubernetes really shines on the CRUD tasks, the updating of a service, the full life cycle management of something, deleting it, taking it down, doing a rollback if you have a bad version deployed to production, doing canary deployments is easy. It makes it really easy to manage all of that stuff without a lot of fuss. We've had some customers switch to Tectonic, which is our distribution of Kubernetes, and they've gone from 7-week release cycles, like planning, making sure they have all the right SQL queries to roll stuff back, blah, 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 down to like about 7 hours. So it's been a significant improvement in our experience with a lot of the customers that we work with. It makes it much easier to manage all that stuff. Yeah, so the question is, are these pods hosted on the same node? And how many nodes are running in this cluster? So I think I can do a kubectl get nodes, and it'll show you my nodes. So I have one worker node with W1, and then I have one control node, which is the C1. So that's your classic master kind of worker relationship. So yeah, this is just a sample for running on your computer. We want to be nice to your RAM and your laptop, so we don't run too many nodes on it. But you can run a cluster that it's been tested to work up to 5,000 nodes. And usually when you get to that size, you have workloads that can be spread across multiple clusters. Yeah, both of those nodes are running on Vagrant on VirtualBox, correct? So the question was, when I ran the command to update my app to this new version, like I ran an apply instead of a create. So what would happen if I did that differently? And I don't know, let's find out. My guess is Kubernetes will complain, whoops, but it may not actually. All right, create simple deployment. Yeah, so we get an error that simple deployment already exists. And then I can switch it to apply and it should be happy. Let's see if we can catch it actually doing its business. Cool, so it's getting one ready. We are going down to 2, so it's draining the nodes as we're watching it right now. Cool, so that's good. And since those are terminating, interesting question is what we'll get if we refresh this page. We should get the original site since we rolled the version back. Question? So the question is, what happens with shared network resources? It's complicated, like the Facebook status. There's something that CoreOS has created called operators, which give Kubernetes more control over tricky things like shared network resources. So I think probably the best example of how that works would be to look at Rook, which is a Ceph storage file system. It's a networked distributed file system that will probably explain sort of what goes into creating processes like that. Yes, so Kubernetes has something called horizontal auto-scaling built into it. and it has vertical scaling to some degree being talked about right now, I believe. I think if you use a vanilla distribution of Kubernetes, which is to say just the free off-the-shelf version that's totally open source, it's a little clunky in terms of how you auto-scale. I know with CoreOS Tectonic, for instance, it's literally just clicking a button and saying, if you reach this capacity, go to here. I want 5 new machines, spin them up for me, that sort of thing. And you can also set up alerts with Tectonic. Tectonic has Prometheus bundled into it, which means your monitoring and observability is all in the same place for monitoring your infrastructure. So you can have Prometheus alert you, and you can take action potentially based on that alert and have it not even buzz you, or you can be the human in the equation sort of managing that manually if you want to. Yeah, Tectonic is CoreOS, the company I work for. We make a Linux distribution. So when Kubernetes came along, we just said, hey, like, this is how everybody is going to want to run apps going forward. So Tectonic is sort of our best of everything out there, bundled together, integration tested, so it will work. And you get a lot of additional features on top of that, like you can define custom services that do even more cool stuff for managing the life cycle of your applications with our system, that sort of thing. So it's sprinkles and cherries on top of the Kubernetes goodness. Yeah, you can use it for production as well. It's the first 10 nodes go crazy. You can install it wherever you want, and it's great for proof of concept type stuff. I think that's true for a lot of distributions though. So as much as I want to like yeah, use our stuff, you should just check them all out, because I think most of them have some sort of similar offering. Yeah, you had a question as well. It's a good question. So the question was, what is the difference between using the swarm command in Docker and Kubernetes? So swarm comes from a different sort of philosophy, I'd say, than Kubernetes. Kubernetes is built from Google and Huawei, I think Microsoft, Red Hat, CoreOS. Like, there's a lot of big names contributing to the project. There's a lot of muscle behind it, and Swarm is significantly smaller. I think Kubernetes is the fastest growing open source project at the moment, potentially of all time, but it's a little too soon to call all time, I think. So the real strong answer is the Kubernetes community is the difference. The more subtle answer is Swarm tends to be a much simpler system. That's really good. That means it's much easier to set up Swarm, for instance. It's really easy to get going. But when it comes to customizing or debugging or troubleshooting or dealing with the long-term consequences of deploying an app onto that platform, there's a lot less customization, a lot fewer knobs, a lot smaller community support. So there are fewer plugins, fewer options, all that stuff that you tend to get with really popular open source. Cool. So the question is, say I was scaling my application on Kubernetes, and I was scaling from 2 pods to 5, and I saw that my nodes weren't correctly deploying things. What would I do to troubleshoot that? That's a great question. I think for starters, I would just make sure that all of the important system components are working the way they're supposed to. Kubernetes relies on a piece of software called etcd, which CoreOS makes. It's a distributed key value store, so it's built on top of the Raft consensus algorithm. It's basically an easy version of Paxos, which doesn't say much. Like, even the people who understand Paxos are just like, it's fucking impossible, don't do it. And even the guy who invented Raft, I think, said that he had a bug in his own implementation of Raft for 2 years before he realized it, and then was like, ah, crap, well, just use CoreOS's version because it's fine. So we have a lot of companies like CockroachDB. I think TickDB is a Rust key value store that actually take the code that we've written in Go from etcd and just plug it into their own projects as well, because it's so well tested. Checking that that is behaving in a way that it's supposed to is the first thing that I would do. It's a distributed system, so you can run into problems like Byzantine fault tolerance, where something is not working the way it's supposed to, but it's not actually fully crashed yet at the same time. And then beyond that, it's basically checking like that the kubelet is working, that it's running on the host machine, that there are no network partitions, all the basic stuff that you would check on a normal distributed system after that. Yeah, so the question is kind of riffing off the previous question. I had mentioned a bunch of things that you could check, which everybody sort of knows to do when they're working with distributed systems, but everybody always forgets something along the way because they're really complicated. So is there something better than just this checklist that I have magically stored in my head? Part of the answer is yes. A big part of the value proposition of distributions like Tectonic is we automate the operation of everything inside of Tectonic itself. So we've added something called self-hosted Kubernetes to Kubernetes. This is, we've donated it in the form of Bootkube to the Kubernetes incubator. So in 1.5 years, everybody who runs Kubernetes will get it. If you want it today, you have to use Tectonic. We're the only ones implementing it at the moment. What that means is right now, Kubernetes, for instance, uses etcd as its brain. It stores the keys for all the operations that are happening on the cluster there that lives in the control plane. If etcd goes down, Kubernetes has no way to reach inside of its own head and tick the knobs or turn the buttons that it needs to get that running again. What we've done is we've operationalized, like good SREs, basic routines that you have to do to manage that. So you're automatically getting backups with Tectonic of your key value store. You can restore the state if you need to. It will automatically recover from a crash if it happens on your etcd cluster while something's happening, like you're doing an upgrade. It will automatically roll back versions to a previous version if you encounter a problem while you're trying to do an upgrade. So a lot of the small annoying things that you'd run into managing a system on top of Kubernetes is taken care of for you by Tectonic itself, because we've done an incredible amount of work trying to codify all of those simple actions into stuff that's just like no duh. Yeah, it'll happen, and you're only really getting alerted when you need to be alerted. We want you to get sleep at night, and the best way to do that is for us to automate things. So that's part of the answer. The other part of the answer is those links that I shared for the Kubernetes administrator exam. There's a link to this slide deck here if you're interested, but this has other links to take that exam, and that exam actually goes into how to run those fire drills. What happens if DNS goes screwy? What happens if etcd goes down? How do you recover from the failure? All that stuff is covered in that, so just studying for that will get you covered. Cool. Well, I have taken up quite a bit of time, so I'll just say I'll be around after this, and if you have questions, feel free to just walk up and we'll talk. So I'll turn it back over to Tom. Thank you.
Great. Raise your hand if you learned something tonight. Look at that. Awesome, awesome, awesome.